In this figure, we'll talk about ionic bonding and ionization. Ionic bonding is a type of chemical bonding in which one element gives up outer shell electrons entirely to another element. The element that gives up electrons becomes positively charged. It's known as a cation. The one that gains the electrons becomes negatively charged. It's known as an anion. If we look at our sodium chloride crystal down here below, we can see that we have sodium ions that have lost electrons surrounded by chloride ions that have gained electrons. The ionic bond is the electrostatic attraction between the positive and the negative charges of these elements. Now, if we take this dry sodium chloride crystal and add it to water, what we have is ionization. This is true for any mineral salt that we add to water. And that is true because water is a polar molecule. It has a separation of charge within its own structure. And so our sodium charge here, our positive charge, is attracted to and surrounded by the partial negative charge of the oxygen atoms in water, creating a hydration layer around that sodium, while our chloride charge, negative here, is surrounded by and attracted to the partial positive charges of the hydrogen atoms within water, creating a similar scenario. The water is oriented differently, but we're still have a hydrated radius, if you will, of water surrounding this ion. And so any ion in solution is traveling around with these water molecules essentially surrounding it wherever they go. It's important to talk about this because in all biological solutions, our sodium, our chloride, our calcium, our potassium, and so on will be acting as individual entities. They are not in this crystalline salt structure that we see over here on our left. It's also important to talk about ions because in many cases we will have unequal distributions of these ions. For instance, if I put a membrane here and have an unequal distribution of ions on one side that are positively charged, let's say sodium, and a higher concentration of a negatively charged ion, let's say chloride on the other side, we have a separation of charge. This is a storage of energy known as an electrical potential. We're going to come back to this later. There's a couple different scenarios under which this becomes very important in our physiological discussions.